Pre-algebra, Chapter 2, Section 1, Properties and Operations. So our objective is to use properties of addition and multiplication today, but first we have to know what those properties are. So we're going to start off with the commutative properties. In words, you can add numbers in any order, and you can multiply in any order. For instance, 3 plus 8 is the same thing as 8 plus 3. They're just in a different order. 5 times 7 is the same as 7 times 5. You can also see it in letters. A plus B is equal to B plus A. And again, we're just switching the order of the letters. We have the associative property. This is where you get into moving things based on the parentheses. So when you add or multiply, you can group in any order. So 4 plus 5 is grouped together, plus 1 is the same thing as 4 plus the grouping of 5 plus 1. It's just a matter of keeping the numbers in the same order, but now we're changing how they're grouped. The same for the associative property of multiplication. We are keeping the numbers in the same order, but we're changing how they're grouped and where those parentheses are. You can see those in algebra over here as well. I'm going to go ahead and talk about the identity property. It's the same, or it's the sum of any number and 0. Let's see. And that equals or is the number. So the product of 1 and any number is that number. For instance, 4 plus 0 equals 4. So notice the difference between the left side and the right side. The left side has 4 plus 0. The right side just has 4. That's how we know it's the identity property. Left side has 8 times 1. Right side has 8. So the difference between is we've already done that multiplication. You can see it over here as well. The two things these are called the additive identity, which obviously goes with addition. And we have the multiplicative identity, which comes from multiplication. So you're just looking from the left side to the right side. And actually, that's what you'll be doing on all these today. You'll say what happened on the left side compared to what happened on the right side. Well, my numbers are out of order, so I've got the commutative property. My numbers are in order, but they're grouped differently, so that's the associative property. I had 0, and I was adding, or I had 1, and I was multiplying. So I either had the additive identity or the multiplicative identity. So example 1, it says you buy a portable CD player for $48, rechargeable batteries with charger for $25, and a CD case for $12. Find the total cost. Well, total cost is adding something up. So we have 48 plus 25 plus 12. But the thing is if I'm doing this in my head, I can already see that there's something that will be easier to add than the way it's the order that it's in right now. So if I was to use the commutative property of addition and regroup this so that I have 48 plus 12 plus 25, I can say, well, if I take 2 and add it, I'm up to 50. And take the rest of that, so that would be 10. 50 plus 10 is 60. I get 60 plus 25. Well, 60 plus 25, 60 plus 20 is 80, plus another 5 is 85. And the more you do that, the quicker you'll get at it. And that's always a good thing, is to be quicker, to make your mind quicker. Because it doesn't matter if you have a calculator, if your mind can't work through these things on their own. You can't get through it very fast. Example 2 wants us to evaluate, so it simply gives us an algebraic expression for xy. It tells us that x is equal to -7, y is equal to 25. So first I have to substitute for, parentheses, -7 times y, which is 25. And then I'm just going to be using my multiplication. I'm going to look at this and say, well, is there anything that would be easier to multiply? Well, if I go ahead and get 4 and 25 together, I already know that's going to make 100. It's one of those easy ones that we've always had. And you don't have to write this out completely. You can do a lot of this in your head because this is 100. 100 times 7 is 700. And then a positive times a negative is a negative. Let's try another one. Again, we substitute first. I'm going to put my x in. This is -6. This is quantity squared times 20. So this will be, I'm going to first look at this and say, well, the things that are easy to multiply, I have 5 times 20. That's 100. And -6 squared is 30. Negative times negative is a positive. And then we're just adding 2 zeros on here and we get 3,600. So these are pretty easy to do. If we want to simplify, simplify means that we may not have just a single number. We may actually have letters to go in our answers. And so here we're just getting like terms together. So we have an x, we have 2 constants. Well, the constants can go together. And 3 plus 6 is 9. Here I can multiply. So I can take 4 times 8 here and get 32. And then I don't have anything to multiply by the y, so it's just y here. Because it's multiplying, we can get these two together. We do have to remember the difference between multiplying and adding is that we have letters that are already together, so they stay together. We're just multiplying the constants out front. Another way to think about this is using the commutative property of multiplication. If we were to regroup this as 4 times 8 times y, we would have 4 times 8 is 32 times y, which is 32y. So the same answer, just a different way of getting it. So if we want to know what each of these properties is, first we look on the left side to the right side, and we say, well, what happened from the left side to the right side? Well, we just went ahead and multiplied. So we went ahead and multiplied that one. So we get the identity property, or the multiplicative identity is what we're going to call this. So identity property of multiplication. Whoops. Identity property of multiplication. From left to right, I notice that my numbers are out of order. Out of order means that it's the commutative property, in this case, of addition. Yes, I expect you to write it out. Y squared plus 0 equals y squared. I have 0 in addition, which tells me I'm using the identity property of addition. Here, my numbers and letters seem to be in the same order. It's just the way they're grouped is different. So that means that this is the associative property of multiplication. Make sure when you abbreviate associative, you put the ASSOC on there. If I see it as just the first 3 letters, I will count the problem wrong. You're not funny. Conversion factor. It helps you convert from one set of units to another. From 1 foot, well, 1 foot is the same thing as 12 inches, right? So one way that we can write this is we can write this as 1 foot over 12 inches. Well, since 1 foot is the same thing as 12 inches, we can substitute it in, and we get 12 divided by 12 is 1. So what are we going to use this on? Let's go look at example 5. Example 5, the Steel Dragon 2000 is the world's longest roller coaster. Its length is 2,711 yards. How long is the roller coaster in feet? So I'm wanting to take this to feet. So first we have to find a conversion factor that converts yards to feet. So the statement, we have 1 yard equals 3 feet. Well, there's 2 different ways of looking at this. We can look at it as 1 yard over 3 feet, or we can look at it as 3 feet over 1 yard. It's just a matter of which one we need, yard, for this problem. Since we're wanting to convert this many yards, and this is a whole number, so that means it's over 1. So since we're wanting to convert this many yards to feet, it tells me that I want to have yards in the bottom down here. So I go over here and find which one has yards, and I have 1 yard on the bottom and 3 feet on top. The reason I want that is because when I multiply these across, what I want to actually happen is I want to be able to have these go away, because a yard divided by, because that's what this means, a yard divided by a yard is just 1, so I want them to go away and be left with feet. So when I multiply across, I have 2,711 times 3. So I get 8,133 feet long. So our homework, which is on page 66, we are going to start with number 16. It says evaluate the expression and justify each of your steps. So we have, remember, justify means we're writing out what we're using. 32 plus 16 plus 8. Well, here I already know that 32 Well, there's two ways I can do it. I could do 16 and 8 because those are easy to do. I could do 32 and 8. I'm going to choose to do 32 plus 8 plus 16. And that's using commutative of addition just to change those numbers around, because now 32 and 8 makes 40. So we have now, so we grouped here, technically you could call it associative of addition, since I grouped these two together to get 40. And 40 plus 16 is 56. And here I just used simple addition.